There's been a variety of methods that our profession has utilized to better appreciate root canal system anatomy. But what we all agree upon is that well-shaped canals have the potential to be clean canals. Regardless of the method utilized, endodontic disinfection is comprised of removing all the pulp, the byproduct of our instrumentation, the smear layer, and finally communities of bacteria, biofilms. Many clinicians relate to a blocked canal as the inability to pass a 10 file to the full working length. But in reality, especially with the advent of nickel titanium instruments, and with particular emphasis on the cross-section of the file, many blocked canals are in turn blocked laterally. Rotary nickel titanium instruments, especially the radial landed variety, tend to burnish more debris into the lateral canals, eccentricities off the rounder canals, and dentinal tubules than cutting instruments. These blocked anatomical spaces need to be cleansed so we can encourage and promote our irrigants to move laterally into the deep anatomy. There has been tremendous interest in the endodontic marketplace on how to improve clinical disinfection. There's a variety of methods that are either to market or are emerging rapidly for clinical practice. Let's quickly take a look at some of the more popular methods. The Endovac is nothing more than placing a suction device in a well-shaped canal to the full working length. This method is quite interesting. Sucking out debris or liberating it through evacuation procedures is useful and helps us have less flare-ups and potentially allows us to pack better. The Rinse Endo is a German device that is made by the Dürr company, and in this method they use pulsating positive irrigation and suction to better enhance disinfecting. Yet another method that has proven to be quite interesting, as based on the evidence presented in the Journal of Endodontics, is ultrasonic fluid delivery. In this method, a cannula is attached to a ultrasonic handpiece. The power setting is going to move the tip between 25 and 40,000 hertz and dispense the reagent of your choice into a well-shaped canal. As per usual with ultrasonic activation, one has to be concerned about internal ledges, transportations, and broken instruments. Photoactivating disinfection is a very interesting method that was born primarily in Western Europe. In this method of disinfection, a low diode laser is used. The preferable wavelength is 980 nanometers of light. In this method, a solution such as toluene chloride can be flushed liberally into a well-shaped canal, and presumably the solution will move out and enter the cell wall of a microorganism. This is called tagging the bacteria. When the diode laser is placed in the canal and activated, the light seeks out the tagged bacteria and implodes the microorganism, rendering it non-virulent. Plastic endophile is nothing more than a plastic instrument that's impregnated with a diamond coating. As this instrument turns clockwise in a canal, the diamond grit tends to sand and continue to prepare an already optimally shaped canal. This instrument is actually producing its own smear layer, although some evidence has been produced to show its efficacy. The IRRIsafe file is a non-cutting instrument that attaches to an ultrasonic handpiece, and I've already given the cautionary remarks about vibrating metallic instruments below the orifice. The Vibringe is one of the newer devices that has recently come to market, and it's basically like a handheld anesthetic syringe, except in this case the operator is dispensing reagent as the cannula, again being metal, is vibrated. We've seen some movement towards endo brushes, not as quickly as I would have anticipated, but we now see some brushes on the market. The problem with the current market version brushes is the D0 diameters are quite large, on the order of about 50 or 60, which means they don't often get all the way to length on smaller diameter canals. Stay tuned though, we don't know the final verdict on brushes because technology always drives new innovations. The one that you're probably familiar that I've been involved with and our group and team built is the Endoactivator. In this method of activation, we use a polymer which is highly flexible and strong, and it goes into a fluid-filled chamber, is introduced into a canal, and through activation, we use sonic energy to kindly activate the tip. The polymer tips are not subject to a diminishing return on their vibration. They can ride on the walls of prepared dentin and still activate a solution to length and around multiplanar curvatures. There is plenty of emerging evidence on the Endoactivator, and I'll show you just 3 images that were produced at Paris 7 by a postgraduate resident named Caron. And you can see in the low magnification 500x bifidity, both branches have been cleaned. One presumably with the instrument and with reagents, and the other one, the lateral canal, is where the instruments never went. In a higher magnification, you can begin to see the potential for the reagent to move as much as 300 to 400 microns back through the dentinal tubules to enhance deep lateral cleaning. And finally, at 2000x, you can see open patent dentinal tubules in the apical 1/3 of this specimen, and this was around the curvature. If we're ever going to bond obturation materials against dentin, we must debride, remove the smear layer, and finally, all the bacteria when present. My final remark would be, when you look at this rather lengthy list of devices, one must assess the cost to get into the technology, 2, the ease of use, and finally, is there evidence or science behind it to show that it actually disinfects a root canal system.